Hi, everyone. Hello, and welcome to today's webinar on the benefits of drone inspections. We're really excited to have you here today. We have an excellent presentation lined up. Before we get started, I just want to mention this is the first in a series of webinars. We're doing 6 of these webinars on drone inspections in partnership with MFE Enterprises. The goal here is to talk about drone inspections from a high level. So we make drones at Flyability for internal inspections, but we recognize that not everyone only needs internal inspection solutions. So we wanted to create a series of webinars that looks at all the different ways that drones are being used as remote visual inspection tools. So both external and internal, because we wanted to provide content that'd be valuable to anyone considering inspection solutions, not just someone that has the specific use case that we make a tool for. So today is high level, the benefits, then we're going to look at assets that you can inspect with drones, both external and internal. We're really excited to have you here. So let's go ahead and dive in. So the first thing to say, just who's presenting, right? It's me. My name is Zach Dukowitz. I'm the content marketing manager at Flyability. We have Joe Grelowitz on today. He's the senior discipline manager at Middo Inc. We also have Mike Van Overmeyer. He's the Midwest territory manager at MFE Rentals, also known as MFE Enterprises. Oh, sorry, Joe. We got the intro in just a moment. That was my fault. I told Joe to turn his camera on when I introed him, and I kind of did just intro him, so sorry about that. We're going to cover a few housekeeping items, and then I'm going to do proper introductions. So remember to ask questions while you're in today. We won't be able necessarily to answer your questions live, but be assured that if you type a question into the chat pane at any point, we'll be saving those questions for the end when we have a Q&A. So don't be shy. If you have a question that pops into your head, hop into that chat pane and go ahead and ask it. Another question we get a lot that we always want to answer up front: will this be recorded? Will I get a recording later? The answer is yes. We are recording the session, and we will be emailing you a copy afterward within the about 24 hours after. And so to just go over briefly the agenda, and then I'm going to introduce our speakers. So obviously we have the introduction. That's where we are right now. We have a big meaty presentation today from Joe and Mike, 55 minutes. That's longer than we usually do. This whole webinar is 15 minutes longer than we usually do. We wanted really to lean on Joe's expertise. He's got years and years of experience in inspections, years of experience using not just drones, but other RVI solutions. So we really wanted to be able to showcase Joe's knowledge and also Mike's knowledge. So that's why we have a longer presentation. Then at the end, we're going to have a 15-minute Q&A. If you just came for the material and you want to see what Joe and Mike know, want to learn from them, and you want to hop off once the Q&A starts at the hour, totally fine, no hard feelings. Obviously, you can always review the recording later if you want to see the Q&A. So it's really up to you. So without further ado, I'm going to introduce Joe. I'm going to introduce Mike. I'm going to tell you guys what they're talking about, and then I'm going to hand things off to Joe. So Joe Grelowitz has worked in industrial inspections for over a decade in several different industries. He has in-depth experience with a range of remote visual inspection tools, including drones, and he's leveraged drone technology to help his inspection clients improve safety and realize significant savings in their operations. Those are two of the benefits, safety and savings, that we'll cover today, but there are more. Joe currently serves as the Senior Discipline Manager in the Inspection Services Department, as I already mentioned. He's at Middo Inc., and I'm really excited to hear what he has to share from his years of experience today conducting inspections in the field. We've been working on these slides, and it's really impressive, the depth of Joe's knowledge, so we'll get there shortly. I'm also excited to introduce Mike Van Overmeyer. He has an extensive background in inspections, and he holds multiple level 2 non-destructive testing, or NDT, inspector certifications. For the last 5 years or so at MFE, Mike's used his inspection expertise to help professionals leverage robotic solutions for improving their inspection workflows. He regularly leads trainings on the Helios 2, Flyability's flagship drone for internal inspections, but he also works with other RVI solutions. He has a wealth of experience to draw from when talking about how drones are being used in inspections, both indoor and outdoor scenarios, and all the benefits that inspectors are realizing from the use of drones. So points to cover. We wanted to organize this. We didn't want to just dive straight into benefits without providing some context. So we're going to start today with Joe going over why you would want to use a drone for inspections in the first place. You shouldn't obviously walk into a situation thinking that you have the solution before you know what the problem is. So Joe's going to go into some detail about how he first started using drones, his history with RVI and inspections, and how to get ready for a successful inspection. Then we're going to dive into the benefits. That's the title of the webinar, the benefits of drone inspections. And then we're going to look at some specific use case and assets with some very concrete benefits. So if we say savings, we want to put $1 to it. If we say safety, we want to tell you what that means. So without further ado, I'm going to hand things over to Joe and Mike. And yeah, take it away, guys.
All right, now's my time. All right, thanks, Zach, for the introduction. I really appreciate it. Thanks for the opportunity to be part of this panel. It's an honor and a privilege. By no means am I the expert in drones and the whole industry, but I like to think that that I have a nice combination of experiences and knowledge and skills that tie different things together. And I try and provide services to my clients and solutions to my clients that keep people out of harm's way, improve safety, decrease costs. So like you said, why use drones for inspections in the first place? So really utilizing drones or any other remote sensor is just another way to collect high quality data without putting people in harm's way. Decreases the cost to perform those inspections most times, and reduces downtime for the equipment owner, which translates into increased production and profits. Additionally, there's a lot of work and data sets that you can capture with drones that you can't replicate with handheld devices. Photogrammetry is getting there with sensors on cameras and phones, but when you talk about LiDAR, you talk about other things that drones can carry and the vantage points that they can attain very easily and safely. You can't replicate that with humans. So a drone, it's cliche and often used in the industry. I've been using it for years, but drones are just another tool in our tool belt, just like crawlers, GoPros on a stick, any other tool. It's another tool in our tool belt, in our tool case, toolbox that you should consider for collecting data safely. So you have to define what your inspection need is. So what's your objective? Any engineering proposal that we submit or inspection, you need to understand the needs of the client and what the objective is once you complete that project to align everything from the proposal phase through execution and then submittal. So understanding the goals of the client and pair the correct equipment and sensors to meet the objectives of that goal. So you want to define and determine the type and accuracy and abundance of the data that you want to collect. And use the right tool for the job. My dad always says to select the proper tool for the job. I'm not too proud to admit that I've used a crescent wrench as a hammer because it was right next to me when I should have taken, walk in the garage and grab a hammer. I use the right tool for the job, but if you translate that to an industrial sector and take large risks, then there's huge repercussions and harm to equipment or personnel that could be realized by making that careless error. I preach the same stuff to my son. He's 6 years old. We do projects around the house. We want to make sure we use the right tools, wear PPE, do everything that's the right way. So using an inferior tool in those environments and using inferior drone in heavy industrial settings or manufacturing, that's a recipe for disaster. That's starting off the wrong foot, and you're taking undue risk and could be reckless if you do that. So don't take chances. Make sure that you're comfortable with the drone and the drone's suited for the job. Ask yourself, if cost wasn't a factor, what would you use? If you can spend $100,000 on a drone that gives you everything you need that'd be great, but every company doesn't have that budget, and every client doesn't want to pay for those services to that high cost. So understand what great would be. You know, the best of the best drone and sensor. Work in your budget, figure out what you can afford to purchase or rent, and see what you're giving up by making that sacrifice. The cost of the drones and the sensors are coming down drastically, and have been over the years, and the capabilities and sensor clarities are increasing exponentially. So you can collect a lot of data safely and better than you could several years ago with inferior cameras. And know that sometimes the drone's not the answer, and I mentioned earlier, but a GoPro and a stick might be your solution. So keep it simple, keep it safe, and try and figure out what's best to meet the objective. When you talk about experience, what experience does your company have with that particular application, and the people that you employ? Are they familiar with that type of work? Is there certain training that you can consider taking to gain that level of education to conduct the project to meet the objective of the clients? And then a big thing for me is being comfortable in the environment that you're operating in. You can be a great drone pilot, but you've only flown in the field. When you talk about making that transition to an industrial setting, I know my first day in a steel mill, I had my head on a swivel trying to take in all the sights and sounds. There's a lot going on, a lot of sounds, a lot of smells, a lot of action, large equipment. So you got to be desensitized to become comfortable in those environments. So make sure you're comfortable in those settings. Take incremental steps and make sure that you're comfortable as you approach that final environment that you'll operate in. In the aviation world, there's a couple key concepts, but avoid machoism. I can do it. That's a huge thing. Don't take undue risk. Don't think that I can do it and it's not going to happen to me. There's no risk for this. It can. You need to make sure that you're prepared to do the work and the project that you have in front of you. And invulnerability won't happen to me. Acknowledge that it really can't happen to you. Next slide. So I entered the engineering consulting sector in 2009 as a structural inspector, servicing heavy industrial settings, mostly steel mills, refineries, chemical plants, power generation, transmission facilities, and assets. Being in the field and learning the industry and experiencing everything about it, like I mentioned earlier, seeing the sights, sounds, and smells of, of those facilities is invaluable. It's something that everyone should go through. Gave me a lot of knowledge and skills to inspect certain structures and provide value to the clients and find actionable deficiencies that would result in remediation of that and mitigation of those deficiencies. This also gave me an appreciation of the hazards that are associated with accessing those structures and what it takes to gain that access with production downtime, manpower requirements, inspection required to do the work, lockout, tag out, and to access all the areas. I was part of a lot of planned and unplanned outages and emergency situations for structural failures that resulted in fatalities. There's a lot that happens in heavy industrial settings that using tools like this or performing traditional hands-on inspections, it's key, it's critical to maintain the stability and integrity of structures. And the use of this type of equipment is a great means to help make it easier to collect that data and have less of an impact on downtime and all the lockout and things that are required so our clients can continue operating, continue making money. Began working with drones in 2015, mostly with visual and thermal sensors. I was an Inspire 1. For those that know that drone, it was great at the time, but when you compare it to what we have available now, it's very inferior. In the environments that I operated in, oftentimes I would lose GPS control So I had to increase safety buffers. I had magnetic interferences, so it was nice to see the 210 come out in 2017 and be able to utilize something that was more suited for industrial applications. Pushback on this adoption of new technologies. So some companies were very eager to see how drones could be used in their facilities, while others watched and waited on the sidelines and let someone else take the risk and work out the kinks before they took it onto their facilities. Really, most times clients were very open to the concept of maybe bringing drones out and lunch and sit down, fly the Helios in a conference room or fly the 210 outside, just to get their hands on it and check it out. Didn't always translate to a purchase order or a chance of a proposal, but it was good networking, and it's a good way in the door to get your name in there and have dialogue with clients. The last bullet point is it's very important to me. We've got to think differently. We've got to adapt or die. I watched Moneyball a couple months ago, and this all kind of came to me and connected. I know it's not a new movie, but it's very relevant to what I do and really what we do as an industry and globally right now with the pandemic that's going on and having to change the way we function, the way we operate, the way we even go to work. Everything has changed in our lives, so we need to adapt. For those that aren't familiar with the movie and the premise of it, Moneyball is based on Billy Beane and the 2002 Oakland A's. He challenged them to operate and think differently because of budget constraints. So he tried to find out how he can win using quantifiable metrics to place value on players. Today, if anyone watches sports, every sport utilizes that model to place value on players, place value on plays, concepts, strategic shifts in baseball. It's all very relevant and all translates to wins. So my point, we must be willing and open to change. Drones being new and unknown, people were resistant to it, externally, internally. So I faced challenges, with my time using this in my employers. So there's people that are not on board with it, but you need to get the chance to prove why it's capable, why it's safe, and then start utilizing it in your workflows. We can't be rest on the status quo. We should know that there's someone else out there that's losing sleep trying to figure out a better way to, better mousetrap, a better way to do something. And if we're not adapting as a company or as an industry, then someone else is going to take that work. So you need to think about those ways, and then that's important to me as I try and go after different concepts and improve things. Next slide. All right, so planning is very crucial for a successful mission. So can you collect data adequately to meet the defined objectives? I touched on that before, but drones, they have limitations. It needs to be known. If there's a lot of debris in an area, then the prop wash is going to blind you, or it's going to cover up areas that are critical for setting eyes on. So make sure that you can collect the data that fulfills the objectives with the tools that you have in the environment that you're working in. Use the right tool for the job. I mentioned that before. On the people that are involved, so it's not a silo. It's not a single person that does this. Internally, you want to make sure you collaborate with your peers, bounce ideas off them, and make sure that if someone else has done a job that's similar to it, or there's a standard operating procedure that you've developed or the team has developed, that you have that for reference to understand the method of operation, the safeguards that you took. On the client side, client maintenance personnel, managers, planners, the people that maintain the equipment, those people, those resources have so much information on the history of the structure, when it was inspected last, how it was inspected, where the problem areas are. So you must engage with your clients, have a team collaborative effort to understand what you want to achieve utilizing remote sensing devices and equipment, and see how that can fit into, but their input, how that can improve your plan, make sure it's safe, make sure that the data that you ultimately collect is actionable. When you start talking about the specifics of the project, you want to identify takeoff points, paths of travel, potential hazards along the way, and those maintenance personnel and the reviewing of drawings and previous inspection reports will aid with that. Understanding airflow, like talking about confined spaces or flight through indoors. Understanding airflows is very, very important. If you can imagine in a boiler, if you launch at the manway and they have drafts going up top, it's going to suck that drone into the boiler very easily. But when it comes time to fly it out, you've got 30-mile-an-hour winds going through a 24-inch opening. It's not going to fly out. So your plan to fly out without breaking the plane is gone at that point. So shut down everything, neutralize everything, understand your hazards and airflows throughout the project. Next slide, please. So this will be between Mike and I. So just really drone quality and recent improvements. I touched a little bit on the equipment that I'm familiar with over the last 5 years, but Mike being in the rental industry, we want to talk openly on this and just have some dialogue on the transition of drones. Mike, if you want to take it.
Absolutely. So, I mean, obviously the way the drones had started was the idea of everything being external. At least from my end of it, everything seemed to start out as an external principle. It's when flyability came into the mix, or groups like flyability came into the mix and tried to turn it upside down, that you started to see introductions of confined space drones or internal drones. Prior to flyability having a product, or Elios even existing in this world, we were seeing clients that would go out and try to purchase a $50, $100, more or less toy drone and utilize it to conduct a full-on industrial inspection. And unfortunately, it's just not the right tool for the job. And Joe, you kind of alluded to this earlier in some of your examples, but using a wrench as a hammer, it's not the ideal way of getting something done. It may work per the circumstance, but it's not the ideal way, and it's most definitely not the way you'd want to continue doing it moving forward. One, for professionalism, two, for efficiency, but just overall, you want to be doing things the right way. And a lot of these sites, I mean, that is a critical component. They want you to be operating well within your means, following the procedures, following the codes, and anything outside of that is just simply not acceptable. So seeing this transition from a $50 drone to a $100 drone to moving to $10, $20, $50, $100,000 systems now, the amount of features and safety features and just abilities that are in these is absolutely incredible. It's allowing you to get into an area previously inaccessible, easier, I should say, faster, cheaper, and just less everything that has to be involved in it. So less people that have to be involved in the process and so much more. I mean,
Yeah,
what are your thoughts regarding some of the ways that this has changed over the last 5 years? Because I would say all of this has been within the last 5 years.
Yeah, absolutely. So I touched on the Inspire 1 and losing GPS. Really, collision avoidance sensors are a great improvement. Really, on the 300, it's nearly 360 around the drone that you can set and make that variable to whatever meets your objectives. But that's a huge one. So for instance, when I was using the Inspire 1, I had to it had a 10, 12 megapixel camera on it to get good data to see a crack or to see a loose bolt or a gap of a bolt. I had to get 10, 15 feet away from it. So I'm taking this risk time and time again in these environments that it just didn't turn out to be great data. And then the 210 came out with the Z30, so that's a higher zoom camera. So you can back the drone away, have a safety buffer, and get that same data from another 3 or 4 times away, further away from the structure. And then that's just those had collision avoidance sensors on it. And then now the 300 has so much more. So it's great to know that the sensors are improving, which keeps you further away, but the collision avoidance sensors are present, so you could get closer if you needed. But it's great that now those things are being put into caves and having LiDAR sensors attached to them. So it's a great transition. It's night and day from where it was when I started.
Absolutely. That's a great way of explaining it. It's hard to think that back when we started with this and the Z30 and things like that first came out, we were working with 1 megapixel or 1.5 megapixel video or quality, more or less, on the pictures. Now to look back and say that we're at 22 megapixel or even in some cases 45 megapixel while maintaining a zoom, that's just, like you said, it's a night and day. It's an incredible difference overall. Just makes them overall more efficient, easier to achieve, to gather the data and to gather high quality data at that.
Right.
So Zach, if you could, let's move on to the next slide here.
Yeah, so there's not much to really talk about this slide. There's just a picture of the Helios 2 and then the 300 we mentioned several times. That came out last fall. So you're seeing a lot of that in the industry. A lot of people are using that for many different uses. Next slide.
Okay, so I'm sorry, Joe, were you saying? Okay. So before we dive into, the full-on benefits, we want to take a step back and kind of cover why you might want to use drones at all for inspection purposes. Zach, next slide. Okay, so the 3 main benefits of drone inspections that we're at least looking to cover during today's discussion is going to be savings, safety, reduced downtime, and reduced downtime for commercial and industrial facilities. Next slide, please. Okay, so there are several areas we're going to be covering on cost savings with drone inspections, including the reduction of need of scaffolding, or what we call strategic scaffolding or strategic inspection, reducing the actual downtime of the plant equipment or the process area that's being inspected, reducing the amount of physical man hours put into a given project. Lowering insurance costs is one that most don't think about as well. Reducing the need for health and safety equipment on site. And lastly, increasing the frequency in which you can carry out your inspections. Next slide, please. Okay, so aside from the costs associated with scaffolding, unexpected damages to the interior surfaces of equipment occur quite often. When dealing with assets that have fragile inner linings or coatings, this is yet just another setback that a plant has to deal with that'll cause additional downtime, additional repair, more people on site, additional man hours. Scaffolding is also a rented structure that has to be inspected daily, which again means more man hours. It may or may not be accessible depending on what's going on in the plant area. It may or may not be in the best position or location for me to even carry out my inspection. Downtime, simply put, kills industry and kills profit. If the process isn't moving at all or near operational capacity, it means the asset owner is losing money overall. Each process area is vital to the overall development of the product and drastically reduces the plant's efficiency the longer it is down. In cases like boilers and superheaters, the equipment must be taken offline several days in advance for the environment to cool off enough for humans to enter. Although drones have temperature limitations as well, the limit is not as low as what it is for a human. For example, one of the most recent consults I had with one of my power gen clients that had a large blowout in a boiler estimated a 4 to 6 day minimum downtime reduction because they were rapidly able to locate the area or the area of concern with their Helios 2, plan and execute the repairs without having to wait for the unit to cool off completely, mobilize larger equipment and or a ropes crew for the initial assessment. And at the end of the day, when they approximated their cost savings, it ended up coming to be about $250,000 to $300,000. And that's just for that single piece of equipment. Next slide, Zach. So reducing the amount of The amount of personnel needed to complete a given task doesn't just save on costs, but it also contributes to the overall more organized work environment. Having too many people on site is one of the hazards during shutdowns at plants that can be extremely dangerous. Plant shutdowns and startups are among the most dangerous times to be on site, and being able to maintain a minimal yet effective physical presence is key to protecting both yourself and your crew. Reducing inspection crew sizes has become possible with the advancements in technology as well. An example of this would be transmission tower projects spanning over many miles. A single crew of 2 pilots can strategically position themselves to take over control of the aircraft miles apart from each other. In doing so, this has allowed them to be able to complete up to 4 times as many towers in any given one day. These visuals previously would have been completed by a helicopter crew, which carries a much, much higher risk and obviously a considerably higher cost as well. Next slide, Zach. Okay. So confined spaces, I'm sorry, let's see. I think we actually skipped one here, Zach.
Yeah, I'm not sure what's happening, Mike. That's where it's going next. Let's see. Yeah, we are missing a few slides, aren't we? I can go back to the original list because it allows you to talk through right here. Is that helpful to talk through the remaining ways that people are realizing savings?
I would say let's go with slide 20, Zach. The hierarchy of controls here.
Got it. There we go.
Thank you. Okay. So industrial plants have their own inherent risks, but the system of controls does exist to mitigate some of the risk that the workers are going to experience at these sites. As you see above here, this is called the hierarchy of controls, and it's a set of circumstances that have been put in place to try to protect each of the individual workers. Your FR clothing, steel-toe boots, hard hat, safety glasses, all of that is your classic examples of your PPE equipment. Administrative controls would be the work practices and or the permitting processes within the plants, such as a low E, a hot work permit, et cetera, et cetera. Hot work being needed for welding and or spark inducing work in most cases. Engineering controls is placing a physical barrier between you and the known hazard. Utilizing new equipment such as drones and the ELIOS is used to mitigate. It's actually a great example of mitigating and an engineering control in use. Substitution and elimination at the very top of the pyramid here. They're not currently possible in all scenarios, but with time and obviously more advancements in technology, we will see more of this. Obviously, with some federal regulations, this may force changes to the industry that cause this to happen a little bit more accelerated as well. And you know, when we come to this type of thing, a question oftentimes that I get asked by my clients is, you know, why are you so passionate about doing this, and why do you want to see this type of equipment used? Well, everyone gets the same answer. So over the course of my time as an inspector, I've had water jackets explode on me. I've been inside of energized equipment while locked out, tagged out on a box and electrical panel, had items dropped on me from above, and we've been evacuated from confined spaces for accidental chemical release. You know, in all of those situations, I was just simply performing a visual inspection in a hazardous area. And I did everything by the book to be safe, because at the end of the day, you have to CYA and you are responsible for your own safety. Had any one of those situations gone differently, you know, I may not be here to have this discussion with you, or I may not even have a face to look at you with. You know, had the equipment that exists now existed back then, I never would have had to have lost, or I wouldn't have had to have put myself in the potential to lose my life and or cause serious bodily harm to myself. At the end of the day, we all want to make it home to our families. And also at the end of the day, you're not replaceable, but your equipment sure is. Next slide, please. Oh, I apologize, Zach. If we could, let's back that up real quick there.
Yeah, you got it.
So a final point that I wanted to kind of explain here on engineering controls, but the initial cost of engineering controls can be higher in some cases than other control methods, but over time, operating costs are frequently lower, and in most cases, some cases, can provide a cost savings to other areas of the process as well. So, okay, on to safety. So as we see here in the chart, this is a NIOSH report or a NIOSH supply chart by the Bureau of Labor Statistics. Confined spaces can often be inspected with the use of caged drones or drones that have some other means of keeping them safe without personnel entry. Deaths within confined spaces peaked at 166 as recently as 2017, which equates to one person dying every almost 2.5 days. This was followed by 148 deaths in 2018 in confined space. Many companies have implemented the use of drones now and robotics to eliminate personnel entry in confined space for inspection purpose. And they have ambitions to eliminate confined space entirely over the course of the next decade. As you see above here in this chart, 9 out of the 12 confined spaces in this are assets and or vessels that many of my Elios clients are flying currently and or have flown in the past. It's just an example to show, like, again, newer equipment can be applied to processes and existing pieces of equipment that have been around for generations. The other thing that we are seeing, and this goes back to kind of advancements in the technology and all of the equipment overall, is robots like industrial RVI crawlers, underwater ROVs, advanced quadrupeds. All of these are now being used as the industry continues to make changes towards safer methods of inspection. Welding robots are even being used in critical infrastructure projects, such as nuclear reactor head projects, where radiation exposure keeps you limited at being in the area for maybe as little as 5 to 10 minutes. In those cases, it's not possible to weld that fast, so we have to have a different means of being able to do it, and not just do it right, but do it safely. So next slide, please. Okay, one more, please, Zach. There you go. And then Zach, I believe you were going to speak on this.
Actually, yeah, let's go back to the hierarchy slide. And we're jumbled around here, but yeah, we wanted to talk through this and give a couple examples on real life case study where we've seen the use of drones. I've seen the use of drones keeping people out of harm's way. So there's two that stand out in my mind. So one, there was a fire event in a reactor that I was called out to fly. It was during a shutdown in a TAR and turnaround, and there was scaffolding throughout the inside of this vessel, and there was some residual coke that lit on fire, and the whole thing went up. So you had all this scaffold, all the planks were gone, but all the aluminum scaffold framing members were there, distorted and warped, and just in a huge rat's nest. So I was called out, and they were sprinkling this thing, spraying it down with water, trying to put it all out. They shut the water down, and they wanted me to scout the area and get some sense as to what was going on up there, and trying to identify any hazards that could be people could be exposed to when they started putting people inside that confined space. When I flew in and tried to navigate around there, like a lot of the areas, you don't know what you're going to run into or encounter. So I got to different vantage points and saw the area in general. And then there was one spot where I found a couple 100-pound door that was part of the process equipment for inspection. It was an inspection door that was precariously placed on some scaffolding. So that was, I mean, I'm surprised it was staying up there, but they were able to water blast that down and remove that hazard before they started disassembling that scaffold. So that's one thing that I did that was really fulfilling, because I saw immediately, what we provided directly benefited all those workers that were out there doing that turnaround. Another really proud project that I was part of, that was a whole collaborative team effort between myself and my team and clients and other contractors as well, was there was a stack, and actually you guys, MFE and Jason from Houston. So there was a stack that was needing to be demolished and taken down, but it was structurally unstable. So the owner and the demolition contractor wanted to monitor the stack throughout the demolition process. And to do that, they needed to place small prisms that were on magnets throughout the height of this steel stack. But to get those prisms on those magnets in place, they would have to put people in harm's way in that fall envelope in a crane and a man basket and drop them down and expose them to those hazards. So they had this concept of, hey, can a drone do this? So the client called me up and pitched it to me, and I had no idea how I was going to do it or if it was possible. But through talking to Mike and Jason and other peers, and the clients and the surveyor, came up with the devices that needed to be placed, the weight, and started to come up with some concepts and prototypes as to how this would actually function. And it was like Rector said from Sandlot, the movie, where there were all these different devices. I bought all this stuff to try and come up with some rigging, but the simplest thing that we came up with was a pole and some insulation from Menards or from Home Depot that was insulation for hot water piping for your house. Yeah. Put the prisms on the magnet at the end of that. This is a huge assembly. This was 10 foot long. So I had to balance it and do some testing against steel doors and make sure this worked and was repeatable and safe. So we put it on a 600, utilized Jason and another drone for a different vantage point to look perpendicular to the pole and see my interface from the prism to the surface of that stack. And first one was set, and I checked my heart rate after that, and it went up to about 150 because I was pretty stressed out. But after that, the other 12 or so that we did they were great. So it was great. We placed all those prisms. The surveyor checked continuity of all of those from the total station that was autonomous, and they were able to constantly monitor the stack throughout the demolition process and do it all. So when they demoed the stack, they did it from above, and then they lanced it and took it down that way. So at no point was any person in the fall envelope of that stack. Those two are a couple of my most, my proudest moments and most challenging projects as well. But things like that are really great to see, and how it directly impacts or saves people from being placed in those scenarios and exposed to those hazards.
No, those are awesome examples, Joe. Those are absolutely awesome examples of this.
Excellent.
So Zach, if we could, let's.
Yes, sir. Yeah. So I'm hopping in just to talk briefly about Dow as an example of a very large company that is very serious about replacing confined space entry with robotic solutions. And Dow is also an investor in Flyability. So just full disclosure, that's part of how I know this, because Dow is looking at our technology, among others, to use so that inspectors will never have to put themselves in harm's way by entering confined spaces. So a few data points to share. Back in 2018, Dow used robotics to eliminate more than 1,000 confined space entries. That same year, they also used robotics to eliminate more than 1,000 external inspections that would have required elevated work. Their goal is to completely remove confined space entry by 2025. So Dow is not the only company that's really serious about the future of dangerous inspection scenarios being all robotics based. There's a lot of other companies, and obviously this data is a few years old. They have more recent data they haven't made public that I'm not at liberty to share, but let's just say that robotic solutions are really taking over when it comes to replacing people in dangerous scenarios for inspection purposes. It's getting to the point where most large companies are having the conversation, you need to prove why you have to send a person in instead of using a robot, instead of the other way around, which is a really heartening future to see, because we do lose people every year in these dangerous scenarios. So that's it for me. I just wanted to hop in to share that. I'm going to hand it back to Mike.
And I appreciate you sharing that, Zach. I mean, that's definitely an initiative that we're starting to see at several different sites across the country. I don't know that I can share all of the names legally in it, but I can say at some of the largest petrochemical facilities, nuclear, coal-fired power plants, anything along those lines, we are starting to see the introduction of this, and in many cases, we're seeing the upgrade of this. So clients that do have this or are utilizing these pieces are increasing their position in that to become even more overall efficient in general. So Going to, or kind of going back into covering some of the benefits of this, the third benefit that we'll be talking about is the reduced downtime aspect. So having the ability to assess a situation or to get a different vantage point can be extremely valuable to an inspection crew and plant personnel alike. Accessing an elevated work area previously included or involved heavy machinery, platforms and ladders, scaffolding, and in some cases special permitting, depending on the site. This can take hours, if not days, to assemble, but it can be accomplished with a drone in minutes by comparison. You know, having access to rapid data collection has allowed the plants to make more educated decisions on what needs to be done. I say needs, but needs to be done now, and what can be rescheduled for later. You know, ensuring the data capture is as high as quality as possible has been paramount to the overall success of drones in the industry as well. It wouldn't have gotten off the ground, pun intended, if we were using older camera technology on newer technology in the air. So it's honestly been pretty refreshing to see the advancements in all of it and how it's kind of led into other pieces of equipment down the line. So advancements in artificial intelligence have also made it to where spot checks on vital pieces of equipment are now possible at the push of a couple buttons. You know, the repeatability of these spot checks ensures the accuracy of the data that's being gathered as well. Not to say that plants don't monitor their assets closely, but there are physical restrictions and limitations in place. There are other aspects of the plant that have to be tended to on a daily basis as well. So if you can overall increase the efficiency, reduce the amount of time it takes to complete the inspection on it, or to take a look at it just to get a good overview of what's going on. Overall, that stuff is what reduces the amount of time you have to physically do it, and just overall increases the efficiency in which you're completing it. So this is great. Zach, if we could, next slide, please. Okay. And more or less one of the last benefits to this is, as far as savings in that, is increasing the amount of actual inspections that take place. So yeah, with the savings established by the drone technologies in the industrial space, we have seen that increase in frequency of people carrying out their inspections, both internally and externally. By more closely monitoring the assets, better predictions for services and maintenances can be established, taking the equipment offline less often, and ultimately generating more profit for the asset owner themselves. Ensuring the data capture is as high quality as possible, as I mentioned, has been paramount to the success of this, but almost all drones are outputting 4K visuals in some form now at this point. But it isn't just about taking pretty pictures. Following those pictures up by supplying actionable data in the form of a report to the end users is what really establishes the difference between data collection and inspection. So you may be wondering how a drone would give you better access within an asset, but simply put, it fits where you can't. And is capable of getting the viewing angles that you'd otherwise have to contort your body, head, and neck to achieve. And lastly, now with one of the newest neat features that Flyability has added into the mix with their Helios 2 and Inspector 3.0 is the ability to have data localization. So in a GPS denied environment, you can now know exactly where you're located, exactly what you're looking at, enabling you to pinpoint a repair service and or better understand the configuration of the asset that you're flying in general. Pairing this localization with other features like photogrammetry, you have the ability to create digital documentation that goes way beyond a picture on paper. In my opinion, if a picture is worth 1,000 words, a digital recreation would be priceless. Next slide, Zach. Okay, and from this point, I believe this goes back into where Joe is going to take off with some examples. And let's see, there we go.
Yeah, Mike, why don't you stay on so we can talk through and bounce off each other a little bit. Yeah, thanks.
Hey guys, here's we enter, just a heads up on time. We're about 10 minutes before the hour. And I think we have plenty of time. I'm gonna stop talking so you guys can dive in. Just wanted to do a quick time check.
I appreciate it.
Appreciate that, Zach.
So we're going to go through a couple case studies of typical assets, ones that I'm very familiar with. We're going to talk external and internal, where they both apply, and either or if only one applies. So stacks, that's a huge savings when you think about trying to inspect a stack on the exterior. If it's 500 feet tall, you need to get people to the top and erect suspended scaffolding and have that go down or do repelling activities. And from the bottom, if you're able, get a tall man lift out there, but to get a 180-foot man lift, you're talking about 10 grand for a day. So it's very expensive to do that. And with all these, we need to understand what we're trying to collect. We're trying to collect visual data for reference. If your objective is to sound something, if it's block, or if it's brick, or if it's concrete, the drone right now is not capable of doing that. Someday it will. I'm sure Flyability is trying to figure out how to put a hammer on a drone and listen to it. So those things are coming. They're going to happen. Just right now, they don't exist. So that's how you inspect it from the outside. It's very labor intensive, and it requires a lot of manpower. And you can inspect the outside of a stack, depending on the size, in 1 to 4 flights. You can get around all areas, see the rain cap from the top, look down. If it's turned off, you can see the brickwork to a certain extent from the top of the high zoom camera on the ID on the interior. So that's very helpful. Next slide, please. So the benefits, again, there's wide range of savings and safety dollar-wise, and then personnel savings based on the size and arrangement and objectives. But there's real savings in implementing drones for these particular services and to meet your objectives and keep people out of harm's way, keep boots on the ground. That's the term I like to use a lot. And then downtime as well. If you think about suspended scaffolding, you may have to shut down the stack to have people up there on the circle platforms at the top. So you can reduce that downtime and perform visual inspections without interrupting operations. Next slide, please. Actually, Zach, I think we had a video. If you want to show that brief video. Very brief.
You got it. Just one moment. There we go. Well, hey, Joe, just a heads up that you're automatically muted when the video starts to play. Sorry, I just realized I don't think I ever told you that.
Thank you. I just figured that out. Are you able to turn down the volume of that? I can just
Unfortunately, it's just a one or none thing with the volume.
That's fine.
Yeah, sorry about that.
We unfortunately can't see the video, guys.
Thank you.
Oh, that is strange. Well, apologies if you didn't see that video. We've heard from some viewers that sometimes you see it when that issue arises, that some people may have seen it, some people may not have, but there was a video of the LEO2 flying inside of a chimney. I'll let Joe take over and go back to the slides.
Yeah, we'll just abandon the videos then. Thank you for the feedback. We do not see the slides right now, Zach. I'm sure you're working on that.
There we go.
Excellent, thank you. So yeah, that video showed the inside of the stack. It described the 30 minutes, a couple flights. They were able to determine that the stack chimney was in favorable condition. So on the inside, same methods. You're talking about suspended scaffolding from the top, or repelling activities. All of those place people at harm's way. Depending on the arrangement, you could fly the inside of the stack without entering that confined space. But if there's several turns that you have to navigate through, you may have to enter that to operate from a certain point. But you can keep boots on the ground fly the full height of the stack, and then pair that with your external data and have a good data set to determine a path forward. And the cost is minimal when you think about it. I think that's the next slide, talking about the cost on the inside.
Let's see. There we go.
Yeah, thank you. So downtime is very minimal. Savings is realistic. It's very real. So you think about those rappelling activities or scaffold activities, that's a large cost to an owner, and that can be eliminated by using drones. And if you do find something that's actionable, you can refine your approach and only access a certain point, the north quadrant, to look at the SIMS platform or SIMS probes area where you have some degradation, delamination, whatever it may be. So you don't have to inspect the full thing. You've inspected it, and then you need to get hands-on 5% of the total surface area. So let's reduce that down and spend money and dollars wisely. Next slide, please. I know we only have 3 minutes, so we'll run through these quickly. So tanks, really on a shorter scale than the 400 or 500 foot tall stack. You can inspect the outside of these with the drones and the roof. Mike, if you want to quickly touch on the magnetic crawler capabilities.
Yes, so the idea that along with visual inspections, you can pair them safely with other pieces of equipment, like Joe had just mentioned, a magnetic ultrasonic thickness crawler. You can take these and just simply run them up the side of the vessel to achieve the same type of thickness measurements that you'd be achieving from the inside. Depending on the situation. Now, sometimes this isn't possible where tanks or vessels would be lined or with insulation on the outside. But in many of the cases that we've dealt with, and many of the cases still out there, these types of crawlers would be absolutely beneficial and are obviously one of the biggest things that are coming up along with drones. And at some point in the future, you may even see UT by drone. We'll see.
Yeah, thank you. Next slide. So the benefits externally, you're eliminating scaffolding, keeping people out of harm's way again. Depending on the size and scale, those are the dollars that you could potentially save. And again, safety, field exposure hours, that can be 100 or 10 to 1,000 or 2,000, depending on the size. Next slide, please. So internal tank inspections, same concerns on operations with vent or drafting. You want to make sure that you can safely pass through and then fly out of a confined space with that. But say a 150-foot diameter tank with a fixed roof, with the Helios 2, you can fly 6 flights and take care of that. Look at all the framing members and do a structural assessment with that data set you have. Next slide. I know I've got 1 minute, so we'll try and burn through this real quick. Just a couple photos. These are actually Flyability's website. Next slide, please. Try and push through one more. So boilers, I mentioned those earlier. There's a huge savings when you consider drones, and there's magnetic crawlers that take thickness readings and map out the tubing, your burner wall tubing, and map out all the corrosion and thickness loss on those. So there's a huge push and case use for advanced robotics to do these inspections and collect that data. So you can, depending on the size, you can fly a 12 burner boiler in 4 to 8 flights and set right in there. I've actually landed inside the burners and looked around and looked at the circumferential welds inside. So there's a lot of different ways that you can approach that.
That's I appreciate you mentioning that, Joe, because that's easily one of the best advantages to Helios, is being able to kind of get into that area that you can't get posting up in, literally landing on top of something in there to gain yourself that best vantage point. That's one of the things we have to cover quite constantly when it comes to training and teaching that mentality. So I really appreciate hearing you bring that up.
No, thank you. Next slide, please. So this is Elios 1, obviously, with the cage that you need to look through. But this is a great example of what can be found utilizing this equipment. So you can stay out of the confined space, not break the plane. So there's a whole permitting and lockout tagout elimination to that, and fly in there, take a look at all your critical components, and give those to the subject matter experts and talk through it, identify deficiencies, and figure out where you do need to rappel down. Instead of 3 different points to cover those 12 or 4 different points to cover those 12, you just set up once, get the middle 3 or 4 burners, and adjust what you need to, and then move on with your day. Next slide, please. So this is the last one, Zach, if we can just push through this, and then we'll be done with the case studies. So crane runway inspections. There's crane runways that are outside, but really I'm just covering the Elios use of those. Here's an example, a photo of how crane runways are inspected with different equipment and getting hands-on inspection. So you've got to shut down the crane, you've got to use flagmen or barriers, or ground people as a safety person, and get up there and then perform the hands-on visual inspection to do this work. This is very time consuming. So in a 1,000-foot runway, you're putting a crew of probably 4 people out there, 1 or 2 man lifts, walking the top side and seeing all these and performing those inspections. With the drones, that can be completed 1,000 feet or so in 15 or 20 flights, flying the faces, flying the tiebacks, flying the seat bolts, and all the different components to determine cracks, missing bolts, shear bolts, any deformation. But knowing that right now, if there's something that you need to hit, because you do find bolts that are loose by tapping them, we're not currently able to catch those things. So understand the limitations, understand the capabilities, make sure that all parties, all stakeholders are understanding and knowledgeable and in agreements with all of those. And there may be times and will be times where you need to shut down the runway and perform a hands-on inspection, or where you find certain deficiencies, or going back to those maintenance personnel that know everything about this equipment, maybe you refine it to the southern 3 bays or the area where they load and unload. And those are the high stress areas, the high usage repetition areas, and that's where you're going to get cracks and missing bolts. So refine your approach. This doesn't replace in full, but it does fine tune and give you a better use of your money. Last slide. And then savings on that, and really the savings is just the inspection portion of it. When you don't shut down and you continue to operate, what's that? I mean, how much do you save there? How much revenue do you maintain or gain by production? That varies by industry. Steel mill could be $1 million a day if they're shut down. Other manufacturing plants could be more or less. Varies widely. Next slide. That's it. Thank you.
I think that, okay, cool. Thank you guys so much. I think just based on the questions and the chats that have been coming in, people have gotten a ton of value out of everything you just covered. So I just want to say thanks on behalf of the audience. I think people learned a lot, and we have some questions. I think if you guys are okay with it, we might go a little over the 15-minute mark for questions, because I think we have enough questions. It's in this sweet spot where we probably can get them all answered in the next 12 to 15 minutes. Sure. Real quick, before we dive into questions, just a reminder, in case you don't know and you're watching this, we have a ton of other webinars we've done. The list on the screen is starting way back, kind of at the beginning of quarantine. We transitioned. We were going to have a live conference. We turned it into a webinar series. So if you see any topics of interest, I'm not going to read through all these, but you can visit our webinar page on our website, and you can see all the different webinars that we posted. And give me just one moment. The one thing I really do want to say, though, again, encourage you to peruse past webinars, but remember that this is webinar 1 of a 6-part series. The next webinar is on whether you should insource or outsource your drone program. I think we had a question from Hannah asking, should I just buy a drone and start using it in my company? What would you recommend? So we have a webinar where we're going to dive deeply into that. Not to say that Joe and Mike couldn't speak to that question today, but it's a complicated question. So if you're interested, join us on the 25th, and then we have 4 more webinars after that. So that's my spiel, but let's get to the Q&A now. Last thing to say, I'm going to leave this slide up. If you have questions, if you have an inspection need, Joe is your guy. That's his email up top. If you have a technology need, if you want to buy a drone or another RVI solution of any kind, Mike is your guy. Mike's email is there. And then if you're interested specifically in the Helios 2, Johan is also someone that you can reach out to. That's his email on the bottom. So please feel free to be in touch. Let's see this as the beginning of a dialogue, not the end. All that being said, let's just dive into questions. So we had one question, Joe. I think this is for you, given your in-depth experience in the field. There's some concerns about whether flying a drone indoors is safe because of the possibility of sparks in areas where there may be latent gas or something like that. They were specific. This is from Blake. He was specifically wondering about sewer inspections, but I think that question could apply to a lot of scenarios, like maybe a boiler, other scenarios where you are flying indoors and you're worried about a spark from a drone. So I'm wondering if you could take that, whether that's a concern and how you address it.
Sure, it's a huge concern. These are non-intrinsically safe devices. They are spark producing. They are just like you're going out there with a DeWalt drill in these environments. They are going to act the same. So understanding those environments and what are the safe procedures to access a boiler or access a sewer. How do you get that equipment in there previously, or people in there? You do gas testing at the entry points. Where you're able, you bring a gas tester to an internal point if you're able. I've equipped 4-gas monitors on a 210 or 300 to fly in refineries that have those concerns in open air. If you're using robotics, you can put a 4-gas monitor that has remote sensing. Have a handheld device that sends you that signal. You can utilize that and then sense. Putting those on an Helios, it's not equipped to carry that type of payload right now. I'm just like the hammer on the Helios. I'm sure that the guys and girls at Flyability are coming up with creative ways, because this isn't the first question for a reason. I mean, I'm sure you get this a lot. This is a lot. A lot of people are concerned with this. So I'm sure they're addressing and trying to come up with a method to do that. But really, you need to understand your environment. You need to come up with a method to remotely sense that, or get a detector in there somehow. So keep that as a concern. That's all I say, and talk through it. It's a hazard that may cancel your project, but it may find a solution to overcome that.
Thanks very much, Joe. We have an interesting question from Mariana, who's asking, in the case of an emergency evacuation while you're conducting a mission, if you're evacuating due to an accident, what are the reaction steps? Would you abandon the drone? What would you do?
So this is forcing people. Let's assume this is forcing people out of the area. So what do refineries tell you to do when you're in an area that you have to get out of? You need to safely shut down your equipment. So I would determine how long would it take to safely shut down that equipment, and the only way to do that is to return it to the takeoff point, because that, just like question 1, that's a non-intrinsically safe device. So if you're leaving that somewhere, it's going to continue to have that spark source. Mm-hmm. So in that scenario, I would say fly it out if you're able, under the time that you think it will take to fly it out, and then shut it down, shut your controller down, and evacuate the area. If it's an area that's open air, it's no concerns with intrinsically safe devices, then you land it. And again, drones are replaceable. Mike had it on one of the slides. People are not. So land it and get out of there. If having that drone in an environment is going to cause harm to people, then you want to try and get it out. But if you're putting yourself in harm's way for something that could be in there and just stay landed, then your priority, your safety is your number one priority, and those of your peers.
Joe, you couldn't have said that better.
Thank you, guys. I have a question. So obviously we're looking at things through the lens of an inspector, looking for tools and realizing maybe a drone is the right tool. But we have someone in the audience, his name's Scott, who has a question about the other side. Let's say you're a drone service provider looking for work and you see an opportunity getting into inspections. So here's Scott's question. Part 107 pilots aren't necessarily certified industrial inspectors. How does the inspection industry treat this situation? Does OSHA require 107 inspectors to certify in a given discipline? So I guess really just, if you're a drone service provider with a Part 107, can you break into inspections? What might that look like?
So I can speak a little bit on this, and Joe, then if you'd like to take it up, you can. But data collection is what we would call that. It's just simply a data collection thing. The FAA and your 107 license wouldn't have anything to do with the professional certifications that you'd achieve over the course of an inspection career, such as like magnetic particle penetrant inspections, ultrasonic inspections, visual inspections, and so on and so forth, for so many more to go. That is something that you would physically go to receive the training for yourself. In lieu of that, if you do not have said training or that type of experience, you would be deemed as a data collection person or a data collection analyst from our end of it. You would then be paired with an inspector or with an inspection crew that would be overseeing the data that you collect. Those personnel, while they hold the certifications to perform those visual inspections or inspections in general, they do not hold the 107 license. You, if you do, that would be the area that you kind of, or the thing that you offer and bring to the table to that crew. So you would be listed as the main pilot, with them being listed as your secondary inspection crew, or again, the ones that just kind of overview your data and explain what you guys are looking at.
Excellent.
One thing to add, so the FAA doesn't control airspace under roofs. So oftentimes the use of the Helios or any other indoor application for drones does not fall under the FAA regulations. And Part 107, although it's good to be forward facing with that, and it shows that you have a level of credibility, those don't apply, those regulations, and they're not relevant to that type of work. So for what it's worth, that's just a point. So a lot of the work that you're going to do may not require that Part 107 if you want to fly indoors.
And I honestly appreciate you mentioning that too, Joe, because that's one of the biggest misconceptions I run into with a lot of my clientele, especially newer clientele that are trying to break into this, is just simply, do I need to have the license in order to operate this? Well, the short answer of it is yes and no. It depends on what you're doing. It depends on where you're going to be flying a lot too. As Joe said, indoor assets or inside of an asset is not regulated space. So you, as far as I'm concerned, or as far as anything I've read, you are not required to have that 107 to perform that, but the outdoor ones you would. So I appreciate you bringing that up, Joe.
Yeah, and one thing I would encourage is to go through the training that MFE provides. Mike, his facility has a great little course, a couple sea containers with a bunch of obstacles. So like I touched on earlier in the presentation, get acclimated, get familiar with different arrangements before you think that you're capable and experienced enough to go into those true hazards in the environments. It's a lot better to bump into things and have some oopsies in Mike's office in a controlled setting than at a client's facility.
Exactly.
Thank you, guys. We're just going to do one last sort of group of questions. We've had several people who are asking about the cost of hiring someone to do drone inspections. So Mariana's asking, what's the approximate cost for an internal inspection in oil and gas or in maritime, for example, for a ballast tank? Hannah's asked, are there approximate costs for a utility power plant inspection? So instead of, I think, going into the weeds with like this scenario or that scenario, Albert has asked, how do you price a drone inspection? Is it simply an hourly rate? Are there other things that come into the, into consideration? So I was wondering if you guys could speak generally. I think what we're seeing is people are wondering, how could I hire someone to do this at my company? Like, what's the first step? What would pricing look like? So I can ballpark it, start to make it concrete. And so I'm wondering if you guys could speak to that. Joe, I think this is probably best for you, but Mike, if you want to jump in too.
Yeah, sure. It's a great question, a great group of questions, very relevant. I get a lot, and I'm sure I'll get it again when I talk to other clients. So there's a number of different ways that you can go about it. This equipment is not cheap. So to purchase it, you're making a substantial capital investment, and that equipment needs to be recouped. So when you get a quote, to answer your question directly, it could be an hourly rate that factors in the cost of that drone, the purchase and the training, everything that we're talking through here. More often than not, it's not really an hourly rate because you have to go somewhere. A half a day or a full day is generally the lowest increment of what I propose because of everything that goes along with making a trip, using that equipment and getting site access, all of that. And depending on the use. So if you just want someone to go out and fly, look at a particular thing and give the owner the photos or videos, the cost would go down. If you're looking for someone to provide a 3D model and use photogrammetry and then localize those deficiencies, find the deficiencies, write a report, all of those incremental adders, a la carte adders are more costs. So I'm talking a lot here in different things that would affect the cost. And when it comes down to it, myself or others need to understand the objective, understand the location, understand the hazards, and then come up with a rate. Very seldom will I say it's going to cost this because there's too many unknowns. You need to ask questions. You need to have all that dialogue with the stakeholders to get aligned and give a quote that is lowest possible to meet those objectives.
That makes sense. And I encourage you, if you're one of those people who ask one of those questions, or if you're on this webinar and you're curious, reach out to Joe. And if I know Joe may not be the right guy to answer the specific question you have about pricing, but I'm sure he knows someone within Middo Inc. who is the right person. So please reach out. The emails that we have up here on the screen are for your use. So definitely get in touch. I think we're going to stop it there unless Mike and Joe, if you guys have anything else that you want to add before we wrap.
No, just a huge thank you.
Absolutely. No, a huge thank you to the group, to everyone who's put the time in on this, to everyone that's logged in to participate in this. Obviously, we couldn't put this type of stuff on without everyone that's joined. So very much appreciate everyone making the time to be a part of it.
Thanks, you guys. And I want to thank you again, Joe and Mike. This is I think the most prepared webinar I've taken part in. These guys spent a long time getting ready for you. So I think we all benefited from their expertise and from their preparation. So thank you guys very much. Echoing what Mike said and what Joe said, thank you if you attended. We really appreciate having you here. Please use the emails on the screen. Please be in touch. If you didn't get your question answered, please reach out to me or to anyone who might be able to answer your question. And we're gonna call it a wrap. Thanks again, everyone.
Thank you.
Take care, everybody.